Hi folks, so this lesson is about Faraday's law and Lenz's law, so looking a bit more in detail, following on from the electromagnetic induction basics that we did last lesson. So starting off with Faraday's law states that the magnitude of the induced EMF is directly proportional to the rate of change, so we know it's over time, of the magnetic flux linkage. So it's the change in magnetic flux linkage. Okay, so we might need to try and remember from yesterday, or from last lesson, sorry, that magnetic flux linkage is the product of the magnetic flux and the number of turns. So magnetic flux, number of turns, and remembering that magnetic flux is the product of the component of the magnetic flux density, so the strength of the field, perpendicular to the area and the area. So have a look back at 23.4 electromagnetic induction if you need to do a bit of a recap on that. So this actually has a constant of proportionality of -1, so we can turn it into an equation where we've got the EMF is equal to minus delta n phi over delta t. In a minute, when we talk about Lenz's law, we'll talk about why it's a negative. So you can use something called a search coil to measure the variations in the magnetic flux, and that kind of goes on from this equation. So so you need to know about search coils. And this is basically a wire with a known number of turns and a known area. And so the wire would be placed into a magnetic field, or the coil would be placed into a magnetic field and removed quickly. So placed in a magnetic field and removed quickly. Oh, I should probably mention we would want to connect it to an oscilloscope. So if we placed it into the magnetic field and removed it quickly, it's going to induce an EMF across the ends of the wire. If it's connected to the oscilloscope, then we can measure EMF. And if we remember from last lesson that our n phi is equal to band cos theta, so we could then have the EMF is equal to minus so if you knew the time that it took, then you could then work out what the magnetic field strength, what the strength of the magnetic field is, so the variations in the magnetic flux, or if you know the magnetic flux density, then you can work out the induced EMF. So this is useful to kind of know, and we'll do an activity on this later on.